ourselves and also organizers of multiple meetups, where React Native and React Amsterdam meetups are the main ones for us. And following our recipes list on Meetup, actually we feel that it's one of the biggest events, JavaScript-based, overall in Amsterdam. We haven't saw actually any other bigger event than this because 150 plus, reaching even till 200 of our recipes is really a big number for us. So thanks a lot for that. Thanks for being here today. So we'll first have a small intro where we give you a few announcements and also present the supporters of our event. And in around 5-10 minutes, we'll be ready to start. First, I'll present myself. So my name is Robert. I'm working at Liberty Global and organizing quite a few events. So this is one of them. And together, under the brand of Front Amsterdam, which is also the name of our staking company, which we are doing the first React conference this year. We're organizing quite a few meetups and 2 conferences next year, which I will also speak about a bit later. We also have a nice banner, similar to the one we see on the screen right now. The organization that's called Front Amsterdam is basically focusing only the educational events, and our plan is to build more events like this and raise the quality bar, not only for our events but also for all the other around. Of course, all of our events wouldn't have that happened without the supporters. So these event supporters are Front and Front Revolution. So you probably heard about Front Revolution. They currently have quite aggressive marketing all around, but yeah, we also had a mistake recently with sending out the wrong link with the update recipe email. Sorry about that, but they are supporting us, and we try to not give a mic to anybody else in the intro except us to keep it really short. So Front Revolution website is like a new job board for front-end developers, where they aim to gather all the front-end vacancies around Netherlands, which is quite a big ambition, but there should be some website like this to make the hiring process more transparent instead of seeing really suspicious presentations of different vacancies without company names, essentially. And Bluefront is a consultancy focused on JavaScript, mostly on the most popular frameworks, including React. So if you're looking for a consultancy to work with or work in, you can also reach to them. By the way, the CTO or CEO, I don't know the title of the person, but one of the main guys is over here with us as well. I think you'll find him somewhere around the back on the left. And of course, if some of your companies would like to support the event to help it grow and to keep up the pace for us and to even step up into the next levels of quality and size and things like that, you can reach out to me or to Denise or to Michael, to everybody who are involved in the organization, and we'll find a way how we can help each other out. Also, as a small perk, this is the thing that you also saw in the email. We always try to communicate with other events and meetups all around Europe. So this time, react.js conference, which is based in Paris, reached out to us, giving us a really nice discount of 20% that everybody of you can use to buy a ticket for their next event. The promo code is React Amsterdam without spaces, but also you'll find a link on the Meetup event page. So if you want to join the conference, please do. This is going to be a really nice event. So if you see there are some nice creators of Vue and or I'm sure there's something from here, but yeah, you should be having always open mind anyway. Apart from that, also one of the big steps for us was that this time we're actually organizing a live stream. Hope that works. This is the first time we're trying to do that during the meetup. And the setup is quite complex right now with my gaming laptop behind your backs and a bunch of wires connected to it. But I hope the quality will be nice because this is also for us really a next level. So apart from video recordings of talks, we also would like to share the lives of the live events. one of the other biggest announcements is also that we finally managed to announce the date of our React Amsterdam conference, which will happen next year on 21st of April. Yeah, it's all over there as well. So you can go to react.amsterdam, or fancy domain name, and check out more details. First speakers and CFP, which is really important, is coming soon. So if you're willing to give a talk, if you have something to share about React or React Native, because React Native will have its own dedicated stream this year, next year actually. If you have some content, please reach to us and use the CFP form that will be announced really soon. We're really looking forward to have more local speakers with really great content, and of course our team is ready to help everybody to do some rehearsals and things like that. So apart from conferences, etc., we're doing meetups, and we're also now looking into doing some workshops. So if you're interested in doing a workshop as an author, please reach to us as well. If you want to attend on a workshop about React Native, let's say, stay tuned for soon announcements, because we'll definitely have quite a bunch of workshops at nice competitive price, which is really important since some of them cost like around 1,000 euros and more. We won't go to that direction. Also, I would like to introduce another new member of our group right now. We'll be doing the full-time event management. It's Diana. You probably saw her at the entrance. She was helping you get inside here. And it seems like it was not successful since you're all over here as well. So if you want to speak about sponsorship or about attending a workshop or giving some feedback or becoming a partner, things like that, you can catch her somewhere here. She's wearing a React Amsterdam t-shirt, which I see actually quite a few people are wearing over here. Good job, guys. Yeah, so the schedule, almost the last thing before the actual content. So yeah, the intro, it's taking less than 15 minutes. Then Michelle Westrat will give a talk about mutable state management, and hopefully he will also share some insights about the MobX tool that he's authoring right now. And then we'll have a second talk by Maurice about supporting large-scale React apps, which is also quite a good thing since more and more people are actually starting using React more actively in production. And yeah, we all are coming and gathering to share more insights on how to prevent some of the mistakes in the future and share our experience. And yeah, by the way, traditional questions. Raise your hands who is using React in production websites right now. Quite a bunch. Not that much yet, like around 10-15%. But yeah, this number is going higher all the time, and the amount of people who see here today always shows that the interest is growing, and the amount of production websites is also growing behind that straight away. All right, so I wish you a really pleasant evening, and I'll now pass the mic to Michelle. Yeah, let's quick up this setup.
So, hi all. My name is Michel Weststraat. The basic problem we saw is that developers are too smart. Besides that, they're also too expensive. So we have to make sure that they don't have to do stupid administrative tasks. I mean, everybody knows it. If you have a developer orders a new keyboard and he has to fill out an Excel form, you get a mad developer. And so we should automate things. That's what we generally do when working in software. So for example, we stopped as a software engineering field, we stopped doing manual releases and instead figured out that using jQuery or something like that, and instead figured that we should have declarative components describing how our DOM should look like without doing the actual manipulations ourselves. And so we figured that we should do the same for data flow. We should use transparent reactive programming that makes sure that data is updated at the proper places. So today I first will talk a bit about MobX and the philosophy behind it. And after that I will show how observable data is actually a more powerful method than immutable data. So MobX is a transparent reactive programming library, and I'll show you in a minute what that entails. And its main goal is to make state management more simple, but also more scalable. And those two goals don't conflict. So basically the idea behind MobX is if you have some data, some state, a person describing me, and you probably want to render that somewhere in the DOM, in the browser. So what you do is you write a component. This is a React stateless function component, which basically takes a person and renders its name. And then you use React, for example, to render it into the DOM tree. The problem, of course, arises when you start changing the data. So if you just look at this code, what you probably intend is that when you change the name of this person, we want to have that name reflected in the DOM. It's in 99% of the cases obvious that that should happen. So why should we care how that is done? And also, if you change the age of that same person, then the DOM shouldn't be updated, because if that would happen and you would have a large application, it would be way too slow. So that's basically what MobX does. You can mark data as this data is observable. It can be derived into something else. Please check it for me. And you can mark a component as observer, which basically means whenever there's relevant data being changed, please re-render it in the DOM. And that's basically it. If you run this code in a fiddle, then you will see that the name inside your DOM will update whenever you change the name, and that it won't re-render if you change the age of the person. And probably you have heard this equation about React. Your view is a function of your state. And actually, I don't really agree with that equation. And the reason for that is simple. If it's just a function, then you still have the responsibility of calling that function. A function in itself is useless as long as it isn't called. So actually, I would say that the view is a transformation of your state. It's just your state, but represented in a different way. And actually, what we want is that it's a live transformation of our state, not a transformation what happens whenever we feel comfortable to invoke it, because we might forget about cases, but it should just always reflect what our state is. It should automatically transform our state into a view. And that is basically what the MobX autorun function does. It takes a function, and it runs this function again whenever some data that is used inside this function has been changed. So if the state changes, then the view is updated. So that means that the consistency of your UI is always guaranteed, whenever, regardless how it is changed or when it is changed. So having asynchronous processes is MobX no fundamentally different from having synchronous process. You don't have to do any special tricks for that. It's just a change of the state in the future. But we know it will react. So the basic flow of data in MobX is that there's a central state which captures all your state of your application, and it should be as small as possible because many things can just be derived from that state, like caches, like the DOM. Those are all just computed values. So from the state, their computed values are derived, and also side effects might be triggered. For example, if you change some data, a network request might need to be made. And so whenever there's an action influencing your state, we know that everything that comes after the state will be consistent. So there are four essential functions in the API of MobX. And one is observable. And it's a function that, or a decorator that takes objects or arrays or primitive values and just make sure that MobX is able to track what happens to these pieces of data. And there's autorun, you just saw it. And related to autorun is observer, which basically puts a React component in an autorun function. So it reruns whenever relevant data is changed. Computed values are very similar. They also take an expression and re-evaluate it when needed. But there's one smart thing about computed values, is that because it's a value and not a side effect, we know when it's needed and when it is not. So if there's a computed value, which is used by nobody, MobX will make sure it's never evaluated. So actually it achieves lazy evaluation. And finally are actions, and those are an optional concept, but they are used to make clear where you intend to change your state. And MobX can optimize around that. So this is what we use MobX for at Mendix. This is an application development studio, and you can drag and widget and change them. They have all properties. So you can build forms and pages. But what's actually more interesting is that we also have a designer in which you can design your database. So these are basically database tables. These are the cross associations. And what we make sure is that whenever we drag things around, then for example you see the arrows moving around. And actually we didn't do anything special for that. Basically MobX just makes sure for us that that is kept consistent. And I'll show you how that works in a simplified version. So here you have the very essence of that same editor, a lot more simplified, but it's powered by exactly the same mechanisms. It doesn't have less or more optimizations or something. The principles are exactly the same. And so what this looks behind the scenes. So what we have here is a sample, very simple JSON JavaScript structure that describes our state. So we have an array of boxes. This is my font. And we have an array of arrows. And for boxes we use classes. But for arrows we just use plain JavaScript objects, just to show that you can use both. So actually, what is interesting is that these arrows, again, have direct references to the boxes we have. They don't use normalization, they don't store strings, they just reference to the boxes. So what we effectively have is a graph of data, because the arrows connect to the boxes, and they're part of the same store. And actually, so far, this application doesn't do anything yet. It has some components. For example, here's a component that renders a box. It has a div with the coordinates. And when you drag it, it will update the properties of the box. But it doesn't do anything yet because React doesn't take care of that itself. It takes care for local state, but not for data you pass into components in general. So what we basically need to do is to bring this application alive, to make it reactive. And so to do that, we just, as I said earlier, we have to make sure our state is observable. So this makes the state observable, and if you have boxes, then you can instead use decorators for that. So by default, MobX will make plain JavaScript objects in their entirety observable. But if you use classes, then you have fine-grained control over which attributes you want to be observable. And with actually is a property that can be derived from another piece of state, namely the name. So that one we mark as computed. And if you run that, then actually still nothing will happen except the sidebar. Apparently the sidebar is observing our state. But the components cannot be dragged yet. But what's interesting is that we actually didn't do anything with our state yet. We kept it in the same shape. The actions weren't changed. They still are straightforward as they were before. And so what we can do now is that we can mark our components as observer. So for example, the canvas component maps over the arrows and maps over the boxes. And observer makes sure that whenever something relevant changes to those collections, it will re-render. So basically, it's a full replacement of the concept of should component update and those kind of things. Because it just means that the components can be derived from the state. So what we can now do is that we can now drag this thing along. And the interesting thing is that the arrow stays connected. And we actually, in this view, we never explicitly mentioned that this arrow depends on the box. But MobX knows that it depends on the box because we're using the from box of the arrow, and from that box we use its x coordinate, so it knows that these values need to be tracked. Actually, you can see that by investigating the component, and it will tell you which pieces of data were relevant for the rendering of this component, and so these exact pieces of data will be observed. So this is a very fine-grained, very optimized way of making sure that the proper pieces of state are used for the rendering and trigger an update. And actually what is nice to look at that was a misclick. So I want this arrow. And we see now that this arrow depends on the from and the to property of the arrow we passed into it, and its x and y coordinates of the two boxes related to it. Now this is what MobX has determined for us. So what's interesting to see what happens if we change, so now the arrows, if you see them, they're connected to the left of the box, not to the middle. That's a bit ugly, so we can easily change that by, for example, using the, no, not that one. Single-handed programming, it's a new achievement unlocked. So now we started using the width of those boxes in our rendering, which we didn't before. So if you now start to drag this box around, you see it's now attached to the middle. And if you inspect its dependencies again, if I can manage to click that one pixel, there. We see now that it also depends on the width and the name of the box. And actually, it doesn't depend on the other box, so apparently I used the wrong one. Okay, I had to use better styling. Anyway, you get a clue. But what is funny is now, if you look, I've made this too hard for myself. Did somebody bring a mouse? Okay, so it depends on the width. And what you actually see is that because the width is a computed value, it's not a value on its own, but it's again a value that depends on another value, namely the name of the box, because the width is just the name multiplied by a constant. So what actually is happening now is that something you might as a developer very easily forget, but if you now change the name of this box, you see that the arrow will move to the right. Because it has traced this dependency tree, and we're now changing the name, and MobX knows that the name is relevant for the width, and that's relevant for the rendering of the arrow. And so these are usually this kind of edge cases you easily forget as a programmer. And then when you finally think about it, then you have to go to the feature in your code that changes the name of the box and make sure that if the box has changed, arrows are re-rendered, which is a completely unrelated other feature. So this means that you would increase the amount of work you have to do each time you add a feature, because suddenly the name becomes relevant for the rendering of the arrow, which wasn't before, just because you wanted to use proper coordinates. So what MobX stands for is that state is the only truth, and that actions and derivations, those things are all decoupled. So actions modify some state, but they don't care what needs to happen beyond that. And then if the state is changed, MobX takes care that the proper derivations are run for you, instead of you having to trigger the proper repaints yourself. So why that is very relevant for us at Mendix, that's because of our architecture. So at Mendix we have these very complicated models. You just saw a piece of it with forms and data models describing what an application looks like, because we built an application to build applications. So we have a large collection of classes, roughly 500, describing all the different concepts that exist in an application, like input boxes, events, microflows, web service integrations. So for that we have a public SDK describing all the things that exist. And then on the bottom we have two IDEs we are building. One is a modeler which only runs on the desktop, so we call it a desktop modeler. It's a C# thing. And the other is a web-based web modeler built using React. And so both those modelers, they operate on the same models of applications. And for each different model, there are separate editors. So you saw just an editor in which you can edit pages, and you saw an editor in which you can edit the data model. And those two editors are maintained by different teams. But those editors have influence on each other, because if I change the data model, then that has impact on the bindings of the input widgets to some entry in the database, for example. So what MobX allows us to do is that we can ignore the fact that those things are related, and all of the teams just talk in terms of the state. So any editor is free to update whatever state it wants. We don't have to tell to each other which kind of actions we fire or something. No, every editor is just free to change the state. And we know for sure that from that state, any other editor is updated if it's using that state. But we don't have to know that because it's tracked for us. So that means that separate teams can individually work on separate features and separate packages, and we still know that everything that uses this data is synchronized. So we don't have to need to coordinate the actions between the different teams. We don't need to coordinate with each other about which pieces of data we're using. The only thing we need to know is what is the shape of the data we have, which classes exist, which attributes do they have. So, and one example where it is very relevant are validation rules. So when is a MobX function, and it just tracks the first function, and whenever that evaluates it true, it executes the second one. And so we have here a function that checks if the speed of a car exceeds the speed limit, and if that happens, then a fine will be sent. So that's basically a side effect will be triggered. Now what's interesting is that it doesn't matter where or when the speed or the speed limit of those concepts is changed, but if it's changed and this equation returns true, we know for sure that the fine will be sent. That's the guarantee MobX gives us. So what are actually rules in our system look like is always a bit like this. They walk over the complete data tree and they check all settings of properties and check if there are no double names and if the correct database type is selected and if the type of the attribute in the database matches the input widget type. It's one big mess. There are hundreds and hundreds of these rules. And so we cannot possibly track ourselves when which rule needs to be fired. But the cool thing is that we don't have to. We know that the correct rules are fired if an important piece of data that influences that rule is changed. And we know that the other rules won't be fired. And so these rules are always visible and all the editors have influence on when these rules are run. But the rules are maintained by, again, a separate team and they don't care when somebody else changes the data. So that is generally what MobX does in its essence. And if you want to look through this in more detail, just take an Egghead course. It's free, takes you half an hour, and then you have seen all the essential concepts of MobX. And I started making this open source about roughly a year ago. And in the meantime, it has grown significantly. It got over 5,000 stars on GitHub. That I'm quite proud of, especially because it's not backed by Facebook or something. And it's also got into the top 1% downloaded packages on NPM. And what amazed me the most was that it turned out to be the second most popular state management library in the recent JavaScript survey. And it's also nice to know that it's not just used in the React world, but also with other frameworks. And people react quite differently to MobX. So what I hear the most is that it's so simple and fast. And it's quite common for people which convert to MobX that they end up with PRs that throw away 30% of their code, which is quite funny. Other people complain that it's a bit magic, it's all happening behind the scenes, it's all done for you. You can't really control it or step through it, or at least you shouldn't want to. But that's the price in principle we pay for abstractions. It's the same what we do with React. We don't care how the virtual DOM works. We just understand its conceptual thing, what it does for us. But we don't actually debug or try to understand that code. And especially when they will be introducing fibers, it will be even more impossible. So yeah, that's some magic, but the idea is that the semantics should be clear, and that is why you should be able to trust it. And the nice thing about MobX is that it's quite opinionated on how you structure your data. You can use a tree, you can use a graph, you can use plain objects, you can use classes. It doesn't care, basically. It's just data and things that derive from data, and how the data is shaped doesn't matter. On the other hand, people are, for the same reason, sometimes sad, because it doesn't tell them how to build applications. It just takes care of some data flow for them. But there's no, this is what your file should look like, these are the proper file names, please use these folders. It's just opinionated about that. And some people are happy that it uses mutable data, because that's straightforward to work with. It matches very closely to the mental model we humans have of the world. It's how we think about things. But on the other hand, people are sad because it doesn't use immutable data. Because immutable data has all these nice mathematical properties. So another question to answer is, should you use immutable or mutable data? Especially in the React world, that's quite a question. Or you could also say, should you use Redux or MobX? Or maybe an even better question, Elsa or Anna? You might be wondering how that relates, but the basic point is I have two small daughters, So this is the question I get the most. They're always arguing over who should play who. So let's talk a bit about Anna. Anna is a very well-controlled, very predictable, very well-behaving girl. On the other hand, there's the previous one was Elsa, sorry. I'm confusing it. On the other hand, there's Anna, and she's very agile and very straight to the point, and she just hates ceremony. And of course, that totally doesn't relate to my talk, so I hope you have read what was on the slides. So, which approach is better? Basically, I think I cannot tell you, or at least I cannot give an unopinionated, neutral point of view opinion about that. But I think the relevance of the benefits of either mutable data or immutable data depends per project. The way of each benefit is different. And although those things are quite opposite, so what may be more interesting is to take a look at what are the driving principles behind those approaches to state management. So Redux is all about predictability. It's called predictable state container. And how does it get its predictability? By providing transactional state. And transactional state means that at any moment in time, you just have your state, you can look at it, it's immutable, it will not change, and then some action happens, and then you have a new state. You can always differ between those two, and you can see the action that have been applied to get from one state to the other. And outside of those actions, nothing can happen or should happen to your state. So that makes it predictable. The word transaction already mentions that. It's like a bank account. MobX, on the other hand, tries to get simplicity by making sure that your state is as small as possible and as many things as possible are derived from your state so that there's no redundancy and those kind of things. So what's actually interesting is that the philosophies of those two concepts are in principle not conflicting. So that's brought me to the quest for a snapshotable state, which is replayable, so that you can have transactions, while still having the convenience of MobX actions which are straightforward and which don't require you to reproduce a whole new world whenever you try to change the tiniest bit. So that's a bit like trying to combine two different directions. So let's go back to my demo. Let's find it. Oh yeah, this is one. So we had this demo, and what is nice about it is that it already supports time traveling. So it can go back and forward in time. That was me being lost. So, but that was the MobX demo, so how can it be replayable? How can it have time traveling when it's not transactional? Well, actually, it's quite simple. What it does is it just serializes the state so that you have a snapshot, basically a deep clone of the state, and it pushes that on a collection of states. So you have a history of states. And of course, that needs to happen when something changes, every time something changes. But that is easy in MobX. We can just put autorun around it. So now we make sure that whenever some data, which is used by the serialization function, is changed, a new snapshot will be produced and will be put on the array. And that's how we can do time traveling. So basically, that is because a snapshot is just another transformation of the state. You just transform it into some JSON tree structure. There are some problems with this approach though. It's a bit limited. And one of the problems is that because MobX is unopinionated, it doesn't know how to serialize your state. if you use just a tree as state without classes, it's easy to serialize and to deserialize. But if you use classes, classes don't have a concept in JSON, so it cannot deduct from your JSON which class it should instantiate. So for that, the serializer package was introduced. It makes it more simple. But there are more problems. Deep serializing your state is very expensive because you need, if you have a large state, you need to walk your entire tree, make a complete copy of that. And it's not only expensive CPU-wise, it's always also expensive memory-wise because you will be filling up memory like crazy by copying your state each time something is changed. So it lacks structural sharing. But these problems can all be solved. That's a nice thing. So what you can do is that we can constrain ourselves to trees, because trees are easy to serialize. And we also know that snapshots are just derived values. And MobX is very good at deriving value. And we even know that we can solve the structural sharing problem, because basically rendering a DOM is also a structural sharing problem. If we change some data, we want the correct components to update, and we want the other components to be left alone. So that's also structural sharing, but just in another form. So apparently these are solvable problems. And to show you how this can be solved quite easily, I'm gonna take first a bit deeper dive into computed values. You already saw them. So here you have a plain JavaScript class, and it has a full name getter property. So each time you inspect the full name property of this object, it will evaluate, and there's something nasty in it because it will return an array. So each time you evaluate this function, you'll get a fresh array. That's a bad thing. So if you change the first name and then you inspect the full name, it will say calculating, and if you inspect it another time, it will reevaluate, give you a new array, and it will tell you another time it is calculating. But actually, if you have observable data sources and reactive derivations, there's inversion of control. So because data is no longer pulled through your system but pushed through your system, it's actually runtime behavior is different. So if you have now two observable attributes and the computed full name, then what will happen if we change the first name, that will trigger the computed value to be rerun. It needs to be derived again because the backing data changed. But after that, if we print it twice, it doesn't need to re-evaluate because it knows that it can reuse its previous answer because there was no data changed in the meantime. So actually, here you have structural sharing in the most minimal form. Both those block statements will print exactly the same array. It's just an effect of inversion of control. So if you apply that concept to, for example, a to-do class, you could give it just a computed value representing the JSON structure, which returns a simple plain object representing the to-do. And the nice thing is that this function will always return the same object unless something did actually change in that to-do item. And if you have then a to-do store with a collection of to-dos, then you can just map over the to-dos if you try to get its JSON representation. And for any to-do that was not changed, it will just reuse the same JSON representation. So what happens if I modify a property over here, a new snapshot, a new JSON representation will be generated. That will trigger the computed value in the boxes collection to be updated. So it will run the map again, but the map will reuse the old snapshots of the other to-dos. Oh, wrong slide, it should be to-dos. Anyway, the point is clear. And so on and so on. So you get structural sharing for free if you use computed values to serialize your state. So that's actually something very cool, I think. So based on that idea, I recently published an experimental package. It's still much work in progress, but it's based on those ideas. And it's, this time, opinionated, so it tells you how to structure your stores. But as in return, you get things like time traveling and structural sharing. And so its core concept is that your state is a tree of models. And those models can be mutable, they can be rich, they can be observable, they can have actions, have computed values. But for every model, there's always a snapshot which is immutable and which represents the state of the model at that moment in time. And those snapshots uses structural sharing. And to create a model, there's the concept of factories. And a factory just gets an example model, and every time you invoke the factory, it makes a copy of the example you gave it. And so basically, it's effectively, it just creates a new observable object based on a copy of the example model, and mixes in any snapshot you provide to it. So if you had some previous snapshots, some previous state, it will make sure that that state is represented in the new instance you get. So a box factory just look like this. It has 3 attributes, those will be made observable, and a computed value. And then we can create a new box by just providing a complete or a partial snapshot. And for the store, the same. There we can use the map of and the array of modifiers so that MobX state tree knows what the shape of this object is and how to serialize it. And the selection this time is no longer a reference like it was previously, it's now a string. Because if it was a reference, then we would get a graph, and then it would be hard to infer how it wouldn't need to be serialized. So it's opinionated, but also a little bit more, you have a little bit more boilerplate than MobX. And we have to see whether that's worth the effort or not. So let's talk about those snapshots again. So basically, there are 3 functions to work with snapshots. You can pass a model to the getSnapshot function, and then you get the snapshot at that moment in time. And you can also apply a snapshot back to an existing model instance. And what's even funnier, you can also subscribe to every time a new snapshot is available. And with that, you can build very easily time traveling while having the benefits of structural sharing and not doing expensive computations. So say we have some store, we can just listen to new snapshots coming in, push it on some array, and then we can easily apply a snapshot back to the existing store if we want to play back or forward. You can also do many other things once you have snapshots. For example, if you have a form, but you want to make changes in that form to some object, but you don't want it that it immediately becomes the truth. You want that state just localized in the edit form until you submit it. So what you can then do is you can just clone the to-do, pass it to the form, and whenever the form is submitted, take the snapshot of the clone to-do and apply it back to its original. And actually clone is just invoking the factory of the model with the snapshot of the model. Then you get a new copy of the exact same instance. And with that you can also make testing very easy, because you can just clone some base data, invoke some actions on it, and then check whether the snapshot represents the correct state. So if we mark it as completed, it should be true. And it also integrates very nicely with Jest. I don't know who has used Jest before, but it's pretty awesome. You can just say, I expect the snapshot to match the recorded snapshot. And then if you change some data, it will give an error, this assertion has failed. And then you should either fix your implementation, or you can just say, this is now the correct snapshot, this change is correct, please store a snapshot for me. And it's really awesome to work with. I can recommend it. Not only for state, but also for testing React components. But there's more we can do. So you just saw this application, but actually there are more of them. And what will be interesting is to sync this application with the other one, which turns out to be very easily once we have snapshots. So what we can do is that whenever we have a new snapshot, we can send it over a socket. I'll try it. And once we receive data over the socket, we can just apply the snapshot back to our existing store. Yeah, that looks okay. So if I now start dragging it, you see on the bottom right all the snapshots of the state being synced over the WebSockets, and those two are kept completely in sync. So that's because we have a way to serialize our state very easily. But there's more. The nice thing about observable data, in contrast to immutable data, is that you know exactly what has been changed inside the data. You don't get a new copy of the complete world, where the only thing you know is that this is the new world, but you can actually see, because it's fine-grained observable, what is actually changed. So the MobX state tree package also supports JSON patches out of the box, which is a standard to synchronize changes of JSON. And for that, it provides two functions: onPatch, which is triggered each time a patch is emitted, and applyPatch. So this is very similar to snapshots, except that it just syncs patches. And patches are, of course, way nicer to synchronize, because if you have a large state tree, these objects which are synced become really, really large, and I wouldn't do that in production. So it's better instead to listen to patches. So if there's a patch, then we want to send a patch to the other side. And if we receive a patch, we just want to apply the patch. So if I now drag, you see there are only very small objects sent along, regardless how big our state has thrown. It's just saying, please replace in this path in the state tree the x value with this new value. That's what JSON patches do. So this you can use effectively to integrate with a backend of some sort. And actually a nice thing about MobX state tree, because it's a tree, it's actually a fractal structure. So it's a tree consisting of trees. So what you could do is not just register a patch listener on the root of the tree, but you could attach a patch listener at any point in the tree. And so then something very funny happens. So I've now attached two listeners to the tree, one to the root and one to a specific box in the tree. And then I start moving one of those, then I start moving that box. Then I get two patches emitted, by each listener emits one patch. And they emit with the correct path relatively to the position they were attached. To put it in a picture, if I change something here, it emits a patch over here with this relative path, but also over there, and describing relatively to that point where in the state tree it changed, and etc., etc. So actually you see it's a recursive structure. Okay, on to actions. You saw that we were just moving boxes by invoking a function. So that doesn't look replayable at all. And we said we want replayable actions to be able to have transactional state. So what MobX state tree does is it reverses the responsibility of the developer. So if you use the Redux, then you have to provide a serialized version of your action, a plain object describing what should happen. But MobX state tree does the inverse. You just invoke a function, and it gives you the description of your action. Because some developers like me are lazy. So an action in MobX state tree is just like this. It's just a function we marked as action. And it can just change that instance of the box. So if you move it, we just update the coordinate, and we don't have to reproduce a new world, a new state here. We can just change this localized object. And so we can then just invoke that box and move it around. But for actions, there are two functions. So we can just listen to the fact that an action was invoked, and we can say, please apply this action back to this object, so we can replay it. And that looks roughly like this. On-action is very similar to the previous ones, except it can be used as middleware, so it receives a next function. And so here we have basically a middleware on the store that prints what action is invoked. So if we then move a box in the store, then it prints, hey, on this path, this and this method was invoked with these arguments in serialized form. So what you can then do, of course, you should know the drill right now, is that whenever there's an action, and we get some data and the next function in the middleware chain, we can send that description over the wire. We can invoke the next layer in the middleware. And if we receive a message, we can just apply the action to our store. So if we now move the box, there are no patches emitted, but descriptions of the action. So we now see that we first moved the box and then we changed the selection, apparently. So that's just to demonstrate that actions are replayable. And you can also do that for forms. Suppose you have a form and an environment where there's collaboration happening. Then you can just clone the object and apply the snapshot back, because in the meantime somebody else might also have changed the same object. Like if you have Google Docs or something like that. So a smarter thing to do is then clone the object.
You have 2 minutes left.
How many? Oh, I'm going to talk very quickly. And then apply it back. Actually, you don't, in the end, turns out you don't really have to have a tree as well to do all these things. You can even do this with graphs. But I'm going to leave that as exercise for home, because I have an article demo. So far we have a state tree which is snapshotable and which has replayable actions. Yeah, all ticks checked. So it's the best of two worlds. But there's one more demo. Last one, I promised. No, not the last one. Last but one. So here's to do MVC, the Redux to do MVC. You might have seen it before. And so here are the Redux DevTools. Yeah. So you can change it and then you can replay it back, etc., etc. You might have seen this before. This is just basic Redux stuff. Actually, the fun thing is that this is not entirely a Redux application. It has Redux actions and uses a Redux dispatcher. It uses Redux components. It uses Redux DevTools. But it doesn't have a Redux store. And it doesn't have any reducers. And still it's replayable. And that's because it uses MobX state tree behind the scenes. And I'd be, how is that possible? Well, turns out, because we have transactional state, we can just mimic a Redux store with a state tree. So what we just do is that we have a simple function that takes a MobX state tree based store and returns a Redux store, and then passes it down to the Redux provider component, and then everything keeps working as is. And the fun thing is that a Redux store function is as simple as this. GetState is basically synonym for get the current snapshot of the state. And dispatch is basically, please replay this action on my state tree. And similar, subscribing to the next version of the world is basically subscribing to the next snapshot. So, and then our store looks more like this, which is, I think, a lot more straightforward. Don't get confused with this uppercase thing. That's because we want to preserve the old Redux name actions. And because we have that, it also works the other way around. So I here have my Redux DevTools again, but now with our original demo. And you see that even in this entire MobX-based application, it doesn't have any Redux in it, the Redux DevTools still work, because it's just, Redux is just a subset of this mechanism. So, just try it out. I hope this was interesting to see this happening. But what's even more important to remember than just this package is that you saw that a transactional state is just one reactive transformation away. Reactive transformations are actually a very powerful concept. It's like if you have normal function applications, which are very static, which you need to invoke manually, and then you have, like, you enter the era of movies and things are actually reacting. So, try the Egghead course, play with this package, and thanks for your attention.
A really short round of answer questions, because I know Michelle will probably leave before we have after talk session. So let's do it just like top 2 questions, short ones. I see here it is.
I see you talked before, so how is this on using it in the production app next month or next week?
The MobX state tree is definitely not ready for this. Just not tested well enough. Not all edge cases are covered. MobX, of course, is no problem. We used it for a long time in production. MobX state tree, I don't have any concerns that it will conceptually not scale. I know the algorithms for that are fast enough. This is just not matured yet. It's just still very experimental. I hope that's the only fun which gets detached for me.
All right. Is there another question? Really important one? Don't be shy. Just one. There's one? No? No? Come on, another. But all right, if everything was clear, then give some other votes to Michelle, and we'll wait for the next one.
Okay, awesome stuff. Let's hope I can beat it. Probably not, but I'll give it a try. So welcome everyone. In this session I'd like to talk about creating large-scale complex React applications. And in fact, most of the stuff I'm going to talk about is not even specific to React. Some of it is, but most of it is more broadly applicable to any front-end browser-based application. So just to give it a bit of context, the experience we gained was building an application to prevent this from happening. This is what was the Deepwater Horizon in the Gulf of Mexico burning down. This was not using our software, so I can't take any blame for this happening. But basically the software we developed was used on drilling rigs like this and production platforms and some onshore sites where they were producing oil and gas. Well, that's kind of heavy industrial equipment, requires lots of maintenance. And maintenance, well, that's kind of dangerous in those places. Like if you've got a gas line and there is a valve in there which needs to be replaced, you kind of have to open up that gas line, which means that even if you close up everything, still some gas will escape and potential for danger is there. Now, by itself, that isn't too bad, but if someone else decides, well, I need to do some welding, I'll go start welding just next to it, then you've got sparks with free gas, and these kinds of things can happen. Not good. So who am I? My name is Maurice de Beyer. I'm an independent software consultant, also a trainer. Most important thing here is my Twitter handle, MauriceDB. I'm going to tweet these, or I'm going to upload my slides to SlideShare and the demos to GitHub, and I'll tweet that. I'll probably do that tomorrow morning. But if you just check my Twitter handle tomorrow morning, you'll be able to find those. So what are we going to talk about? Well, first I'm going to talk about stuff you run into with HTTP, because it turns out that HTTP, yes? Closer? Oh yeah. I can hear the difference. So the first thing I'm going to talk about is HTTP and doing AJAX requests. Because it turns out that if you do HTTP requests on your desktop or your laptop while developing, it usually just works. It's all local machine and really fast. But if you go out on the internet, start using 3G connections or satellite collections like we had to, then it isn't quite as easy. I'll talk a bit briefly about scaling, because scaling takes some requirements, and turns out it's a lot easier if you think about that upfront from the start. Then I'm going to talk a bit about different programming language stuff we did, TypeScript, ESLint, and that kind of stuff. A bit about Webpack as well. And finally, I'll talk about error handling inside of the browser and some of the stuff that can happen there. But first, like I said, HTTP. So the first thing is not actually about HTTP itself, it's about how you set up things. If you've got a real small application, it's fine to just create a simple endpoint on the server. Not the same. You can't remember all those details. It's kind of too hard to remember. So what we resorted to was generating a lot of our code. We basically use Swagger, which is a service you can use on the internet, or you can download it, install it on your own machine. And you describe what your endpoints should look like and what the data is you're going to use. And based on that, you can start generating client-side and server-side contracts. Now, as an example, I've got the Swagger editor open here. And on the left-hand side, you can see the data contracts. We're actually more than a data contract. Over here, let me zoom in a bit more. So that should be readable, I hope. If I zoom in any further, we just won't see anything anymore. But basically, there is a list of paths here. So the path movies. And we can do a get there. And there is some description stuff here. And there is something about responses. So we can get a 200 response, so the basic OK. And it returns something. So over here you can see it returns an array of movies with a reference to how that movie looks. Or it can do an error in case something went wrong. So if I scroll down to the bottom, let me quickly scroll down. Over here I've got my data contracts. So the movie contracts right here. And it's basically an object. It has a couple of required properties. So there is an ID here, which is in type integer. There is a title, which is a string. There are some scores there, which are integers between 0 and 100. There is a, where is it there? There is a cast, which is again an array of cast members, which is down here. This is the cast. So again, an object which has a required ID and a name and how they look. So with this, creating a fixed description of what everything looks like is a lot easier. Next, we need to get our codes, and the online version has a generate client option here, where there is a bunch of options, the same for server. With client, I didn't see all of them, it kind of scrolled out of the screen. But you can see here, you can generate it basically as Node.js or as an ASP.NET 5. We were actually using ASP.NET on our server, so we used that side. And we used, well, TypeScript on the client, which is in here, it's just scrolled out.
but it's one of the options. So that generates a bunch of code, which I've already downloaded. And here we can see the server, all the stuff for the server is in there, a simple node server, a client. And I've got a little demo script with basically just exercises that service. So let's run my server, do all the one-handed stuff. So nodes demo. And you can kind of, well, there isn't a whole lot to see, but you can see that a request was made to the server. At least you can't see that the request was made, but trust me, this actually made a request to the server. And there was no error at the bottom here. It says errors null. But suppose I change something in here. Let's say that name property here was required. And I remove that. And tab back. Now I do the same again. Now you see an actual error. The server validated my objects against the Swagger definition. It was no longer valid, so it was immediately rejected. No code required at all. It automatically does all those kind of checks. So it's the kind of thing you don't want to start with if you've just got a small project. Then it's just overhead. But if you've got hundreds of endpoints, lots of data contracts which you have to maintain, which migrate over time, properties get added, dropped, renamed. You have to make sure that the client and the server-side code stays in sync. Then using something like Swagger helps a lot. So the next thing about HTTP is doing actual HTTP requests. And like I said in the intro, if I do this on my development laptop, it typically just works fine. It's localhost. Localhost is always available. Even if there is no network, localhost is still available. It's fast. It's the local loopback adapter. That takes just milliseconds. So everything runs really fast, and I don't really get strange things. But when you start working with offshore production platforms or stuff located somewhere in Siberia or something, then your internet connectivity is not going to be quite as good. If you run over a satellite connection, anyone know roughly what your average latency is going to be for over a satellite connection? 100 milliseconds. I wish. No, count on a second. It's going to take a second latency for every request. So even if you've got 0 time on the server, a request is still going to take around a second. Anyone know for a 3G network, just a regular 3G network outside of the big cities where you've got really good coverage? Yeah, think about 500 to 600 milliseconds. Just latency. So things are going to be a lot slower. But it's not just slower. You're going to see things fail, just things time out. One request might go through, the next request might not. Now, if you never experience that on your local machine, it's kind of like, well, shit happens. It goes into the field, and there it fails occasionally, but you can't reproduce it. Works on my machine. So we actually made sure that it started failing on our machine, and we had all the requirements in place to handle that. So we had some middleware called the Chaos Monkey, inspired by the Netflix Chaos Monkey. Now, we didn't use their code, we just wrote some code ourselves. It's nowhere nearly as sophisticated as what they've got, but it did a couple of things. One, it would randomly drop some messages. So it would take, say, 5% of the messages and just drop them all together. And it would take another 5% of the messages and would return a server not available kind of error, just maybe a 500 or a 503 kind of status, something where the server can't respond. So we're kind of simulating those errors which will happen in production. And we had code to make sure it worked. So to give you an example of how that works, let's stop this server. And let's start another one. npm start with a T and a single M. It will work better. So this is going to start up a simple server listening on port 400 and a simple React application Just done with create React app, which will proxy some requests to that server. Now that server is set up using that Chaos Monkey, so it will occasionally fail, at least a simple clone of the Chaos Monkey. And assuming my page actually loads, which would be nice if it did today, there it is. You can see there are two buttons here. The first two requests does exactly what it says. It does two requests to the endpoint. The first will respond with one, the word one. The second will respond with the word two. So if I click it, you'll see 1, 2. Well, the one was very hard to see, but it was there very briefly. And it basically does that. So usually, if I click this, it does 1, 2. But you'll see occasionally, we end up with 1. Because we randomly introduce latency here. It's going to take somewhat longer for some request. So occasionally, the request will resolve out of order. The second request will resolve first, and the first request will resolve last, which kind of gives errors. So we actually saw this in production. We had a list of work permits, and the user could click on the work permit to see the details. But they might click on the first one, then click on the second one, but because of requests resolving out of order, while they clicked on the second one, the second request would complete first, and they would actually get the first request or the first work order last, and see the wrong details with the wrong selected item in the list. So there is no simple way to fix this. Let's go to the code. Demo poly, in source, in app.js. I've got do two requests here. And if you want to fix this, and you really want to make sure you receive only the last request, you really should cancel the first request. Turns out that depending on how you do your HTTP requests, you may be able to or may not be able to do so. In this case, I'm using the HTTP fetch API, so the new standard API to do AJAX request. Well, fetch is kind of nice, kind of low level, but kind of nice, but it also does not have a way of canceling requests. So I can't basically say, well, go and cancel the first request because we're starting the second, and forget about it. Instead, all I can do is say, well, if the first request or the second request is started and finished, let's just ignore any results from the first request. So by enabling a little check from, okay, is the request state already set, then that request should work. So now, no matter what I do, we should always end up with request 2 as last. And maybe request 1 was displayed, maybe we just completely ignored the result, but at least it's predictable. But like I said, canceling would be better. Another problem is failing request. That's what the second button does. It does another request and it basically gets the current time. So if I press that, it retrieves the current time from the server, displays it, and it does so again. But once in a while, in fact in this case once every 3 requests, because I've kind of made this fail a lot, it is just going to get a 500 error status back, and it says fetching, but it's basically just failed. So after that, it works just fine again. It's just once in a while, it breaks. So fixing this is a lot easier. There is an open source library called Poly, which I wrote a few years back. And this basically does transient error handling. It will detect error situations. Failing HTTP requests is one of those. But it could be anything. It could be any kind of action you're doing which could fail but is retriable. And this will basically detect that HTTP 500 return status, and if it sees one of those or maybe a timeout, it will just retry the same action. So let me enable that one. and this one. So now I've basically just wrapped the fetch code with a call to poly. My app is retried, and now once in a while it will say fetching, but I've actually told it to delay slightly longer than I normally would. Normally I've got delays of 100 milliseconds and 200 milliseconds, and just stagger it like that. I've kind of made them a bit larger so we can actually see the retry here. And now it's waiting for 1 second before it retries, but it automatically retries and we still get the response. So that takes care of a lot of those HTTP errors. In case of a complete timeout, it's still going to retry, it's just going to take a bit longer, but if there is no response at all, it will detect that and retry just as well. So another issue with HTTP, or issue, it's not an issue per se, but the issue is HTTP caching. So in general, if you're going to do a lot of requests, you want to start using caching for static data. Suppose you've got an endpoint returning you a list of countries. Well, the list of countries in the world doesn't change very often. Occasionally, we'll get a new country, or maybe one will disappear because of some political action. But for the most part, that is relatively static. So that's the kind of data we want to cache. There's also data you typically don't want to cache, or maybe have some kind of version check. Like in our case, permits, they would be changed relatively often. Now we would still want to do some checks to not download the same permit every time. So we use something called e-tags, which is basically a version of the document you retrieve. And the next time you request that, the browser will send that along and basically say, well, can you give me this if it has changed? And if not, just let me know and I'll use the one I've got in my cache. But there is a problem with caching. If you're doing RESTful services, you might use an accept header to do content negotiation. And by default, the browser and other middleware or devices out there will use just the URL to decide if something needs to be cached. So just because you asked for something in a JSON format, now someone else asked for that same cached resource in an XML format, he's going to get JSON instead of XML. He's probably not going to be too happy about that. The same with authentication. You might request something, you might be authorized for it. You'll get that response back and it might be perfectly static, so cached. Someone else is going to ask for it. He might not be authorized to see it, but it's still going to be read from the cache. So there is an HTTP vary header, which you can basically specify in a request, and that contains all the headers that the caching infrastructure should use when deciding whether a cache entry is valid. So always make sure to include at least the accept and the authorization headers in there, but any other headers you find useful. One we added, which we found very useful, is the application version. Different versions of the application might add or delete data. They might change the data structure somewhere. Well, guess what? If you just happen to retrieve a cached version of the previous structure of the application, you're going to run into issues again. So that's another thing you want to add to the vary header. Another thing which is not exactly obvious if you start looking at caching is what happens if you don't specify cache headers in your responses. The HTTP caching spec is kind of very detailed, and there is a lot of stuff there. If you add these kind of headers, this will happen. If you add these, that will happen, etc. Except for one case. They kind of left out one case. The case where you don't specify any caching headers in your response. Chrome and Firefox used to say, well, if you don't specify that something should be cached, we're not going to cache it. We're not going to cache it. Older versions of Internet Explorer said, well, if you don't say we can't cache it, we will cache it. So you'll get different default behavior. That IE problem is mostly gone because IE is slowly dying away and Edge does things correctly. But it's not just browsers that do caching. There is all sorts of infrastructure. Again, if you're working on your local machine, it's just the browser and the server. But if you're going through satellite connections, there will be caching, middleware machines, all sorts of caching to optimize requests. They might not do the right thing. So always make sure to include those caching headers. So scaling is also an interesting thing. Scaling out in this case. Because basically there are two options when it comes to scaling. You can scale out, say, get more machines, or you can scale up, get a bigger machine. Scaling up is typically quite easy to do from a technical standpoint because you've still got one machine and you're adding a stronger, bigger machine, but your whole architecture doesn't change. Scaling out is a little harder. Now you're working with multiple machines. You're going to distribute traffic over different machines, and you can get very different responses for different machines. So the first thing you want to make sure is that you always start with 2 machines, even when developing. Scaling out is hard, going from 1 machine to 2. And with machines here, I'm talking about web servers or database servers, machines of the same category. I'm not talking about saying, well, I've got one machine which has my website or web application, the web server, and my database, and now I'm scaling out to move my database to another server. That's easy. It's going to increase the latency a bit between the two, but other than that, it's no biggie. I'm talking about scaling out in, I'm going from 1 web server to 2 web server, or 3 or 4. If you maintain any form of state, you're probably going to run into issues. You can configure sticky sessions, where one client will always connect to the same server, but sooner or later you'll run into that server not being available and the request actually going somewhere else. In general, always use round robin, and always make sure there is no state. So we use this. We basically had Chaos Monkey again. So anytime in development, we would run 2 copies of our server software with the Chaos Monkey in front, and besides dropping some of the messages, it would also round robin to the different servers. So any potential accidental state we kept on the server would be detected and would show up during development and testing and not in production. So writing code is actually a lot harder than you think. We were on this team with a dozen engineers, at least engineers and testers. They were quite experienced, like there were no junior developers. There was someone who had a bit less experience than the others, but for the most part, these were all very, very experienced people. So we knew we had to get help from all the systems we got. So we started using TypeScript. Now, whether you use TypeScript or another type checker like Flow doesn't really matter. The fact is you want a type language if your system becomes bigger. If you've got a small system, just a few people working on it for maybe a few weeks, then you can remember stuff and everything is fine. But if you've got hundreds of types and services and lots of stuff working together, making changes is going to become harder and harder, especially with a dozen people working on a system. What's the impact of my change? Not quite sure. I change something on the server, something on the client might fall over. Like I said, we were going to generate client and server side interface types anyway, so they would be consistent. But with TypeScript, or at least with type checking, we would know that if we access the property or we're calling a method, at least it existed. It doesn't mean you won't have bugs. It's just a specific type of bug, which will mostly go away. If you do that with pure JavaScript, you'll run into lots of undefined is not a function kind of things, or you're concatenating a few strings, but one of them has a typo, so again you get undefined there instead of what you want. So just use one of these things. We also used ESLint, and because we're using TypeScript, we also use TSLint. We use both of them. Basically do lots of static analysis on our source code. TypeScript prevented the undefined is not a function kind of error. ESLint and TSLint prevented lots of other errors. Missing semicolons, which can do all sorts of weird stuff. Just being consistent with code, with spacing, not forgetting prop type definitions in React. All those kind of things are done with ESLint. Now, one advice, we kind of, yes?
If you use the TSLint, is that still helpful to use ESLint as well?
If you're only writing TypeScript, no it isn't. But we had the combination of TypeScript and JavaScript. Because when we started, TypeScript did not support JSX syntax yet. That's why we had both. But when we started, we kind of figured, well, we're all very experienced. We don't need too many rules. And we kind of created a small rule set and worked with that. We kind of regretted that afterwards because even though we thought we were all very experienced and wouldn't make some basic mistakes, it turned out we did. And I was as guilty of it as some of the others were. So after a while, we decided we had to increase the number of rules in our lint configurations, which means that lots of lint rules were all of a sudden broken and you kind of had to go in and fix them. Now ESLint has this wonderful option --fix. So you can run ESLint with the fix option and most rules it's able to fix. Not all of them, but rules like indentation which is wrong or missing semicolons, it will inject them. And usually it will inject them in the right place, so it will actually fix the problem. Not all rules are automatically fixable though. And for TSLint, the TypeScript linting, the --fix option doesn't exist yet. That's something which they're working on, so that will be there in the future. My recommendation is to start with the Airbnb rules. Airbnb has a very good set of rules. It doesn't cover TypeScript. As far as I know, they don't use TypeScript, but it does cover ECMAScript 2015, it covers React and lots of other cases, so it's very good. Now some of the stuff in there is kind of like, well, your program is not going to break. Like, should you use 2 spaces or 4 spaces indentation? Your program is not going to break if you change that. But there is other stuff like whether you want to validate prop types or not, which could potentially affect your programming or the result of your program. So I would highly advise you to use that. So another thing we used was Webpack. We actually started off with Browserify, but we quickly run into performance issues with Browserify. So quite early in the project, we switched to Webpack. And Webpack is that bundler which will basically load up all your source code and even images and CSS, etc. It can do quite a lot. Bundle that together, call Babel and the TypeScript compiler to transform stuff and produce a couple of bundles to download into the browser. And that worked fine. But we started running into some performance issues. Like, at first, it ran in a few seconds, no problem, but then we kept on adding code and adding code and adding more code, and it started gradually getting slower. And it's one of those things where if you put a frog in boiling water, it will jump out. But if you put a frog in cold water and you turn up the heat, apparently it just stays in there until it's boiled. Well, we didn't stay until it was boiled, or we were boiled, but it took a while before we actually started fixing this. And the first thing was the Common Chunks plugin. That's a plugin you'll read all about, and it's quite common. Like if you've got a lot of common code between parts of your application, use the Common Chunks plugin to remove that common code into a separate bundle, which you can separately download, which is a very good principle. But the problem with the Common Chunks plugin is that common code, like your React, Lodash and all of that stuff, which is completely static, is evaluated every time, which, because it's completely static, is a waste. Like once in a while you'll upgrade React, but restarting your Webpack is not an issue then. So there's actually a better way of creating a static library like that, and that's using the DLL plugin and the DLL reference plugin. It basically means you've got two Webpack configurations, one for your static DLL, that will use the DLL plugin. It will create a JavaScript bundle and a JSON file, which is basically a manifest of what's in there. Then inside your application bundle, when you run Webpack, you use the DLL reference plugin. You basically tell it, well, there's a manifest file which contains all the stuff which is already available, just use it from there. Because all of that's already been done once, it doesn't need to rerun all the time, it doesn't need to be really evaluated, and that saves a lot of code. Because even though we were writing quite a lot of code, it's still like React, Lodash, and those standard libraries were quite a large part of our code. So just removing all of that from our Webpack bundle saved a lot. But it saved a lot, but not enough. It still turned out that all the code we were writing, every time you made a change and you saved, a lot of evaluation was going on. And a lot of code which wasn't actually changed still got evaluated. So it turns out there is this loader for Webpack which is brilliant. It's called HappyPack. And it addresses the issue in a few different ways. First thing it does, it says, well, all of this is JavaScript running in Node. Node is single threaded, so that's one core doing something. And my laptop has 4 cores, so that means 3 cores are not doing anything at all. How about we start using them? So they actually use web workers and start parallelizing compilation tasks, so it runs faster. It starts using the whole machine instead of just a tiny part. But it actually does one better, because that's just the first time you start it, it's already faster, and it's maybe a third faster or something. But then you can specify this cache option. And with the cache option, it starts writing out metadata about everything it's transformed. And then if you restart it, or it has to reevaluate something, it's going to look at that cache and see whether it's actually changed from previous time. And if it hasn't, then it basically will conclude, okay, I don't need to transform this, I don't need to run Babel, I don't need to run the TypeScript compiler and all the other loaders, etc. I can just take the previous result and return that. That sped things up a lot. Now, HappyPack is compatible with most TypeScript loaders. Unfortunately, it was not compatible with TS loader, which is the TypeScript loader which we were using at the time. Turns out there is another. That's the awesome TypeScript loader, which is still not compatible with HappyPack. That's actually an issue in the TypeScript compiler itself, but it implements a lot of the HappyPack details on its own. So even though it does it differently, it kind of has the same effect. And between using the DLL reference plugin and these two loaders, our build times from initial startup would go down from around a minute to around 10 seconds. And incremental builds would be like, well, 0.2 to 0.5 seconds, which was a lot better. That's kind of where you'd like to be. So another issue is errors. Everyone hates errors and wants to pretend they don't exist, but they do. And you can ask your end users have you had any errors? And they will probably say no. And you can leave it at that. You can trust them. But the reality is that usually users will think that they did something wrong, and whenever an error occurs and it wasn't actually a program problem. So if you want to know about errors, you really have to start tracking them. So that's another piece we built. Basically start logging all the errors that occur in the browser. So hooking up the window on error event, tracking all AJAX requests, seeing if errors went, doing anything which was basically asynchronous, adding a catch handler to that, logging all of those, and sending those to the server. Now, one thing you might run into if you start sending those to the server is that the error might be a result of you being offline in the first place. You're expecting to get something back to the server, but the server is unreachable, and that causes a number of other errors. So, as a result, we actually started storing all the errors in local storage. Could use IndexedDB, but we decided to use local storage. And only sending them to the server sometime later. There was actually a second reason we did that. One, so they stayed around if the server was not reachable and we could send them later. But the other issue is, well, you might have an error somewhere in the loop. So you might have some AJAX request return maybe, and you try to reach a property from it which doesn't exist, call a function on it, maybe to string something, and you'll get an AJAX request and 1,000 errors in rapid succession. Do you want to send 1,000 AJAX notifications to the server from each specific error? No. You're just going to eat up more bandwidth, and they're all going to be the same anyway, so you don't need all of them. So what we basically did is said, well, we've got an error window of 1 minute. If we detect the same error with the same message and the same call stack within the same minute, we would just increment a little counter so we would know how often it happened, but not send them individually. So we would basically say, well, this undefined is not a function error, occurred 100 times inside of this minute. And at the end of the minute, we tried to send it to the server. If it was available, we would just remove it from the client. If the server wasn't available, we would just keep on trying, maybe days later, until the client was available. So even if someone took his laptop off the network, put it in a plane, started working in a plane where he was getting errors all the time, well, eventually he would get back into Wi-Fi or 3G connection again. So eventually we would get those errors. But don't forget to do that, otherwise you won't see any errors inside the client. Now let me actually start another server. Stop this one. And show what happens. Ooh, that's not what I wanted to do. I wanted to go here. npm start this project. So that's another simple React application, another one done with create React app. But in this case, I want to show what happens when you have an error when rendering. So this application should load, and there should be a single button, and every time I press that, we should see the current time on the screen update. And it would be nice if it actually rendered. There it is. So you can see 2 times here, the render time and the set state time. Basically, every time I hit this update button, the handler behind that, the click handler, will set the current date or the current time in the state, which will cause it to re-render. The first method, the render time, is actually just a new date inside of the render and displaying it. But right now, they're basically updating together nicely. So let's break this and see what happens. Demo error, source, app. Let's assume I said, well, because we really are only interested in the time part, I'm just going to store the time in the state. But in my render function, I'm still using toLocalTime string on the object in the state. Now, of course, that's perfectly valid on a date object, but not on a string. Then that will cause an error. So switch back, and now if I click update, nothing happens. But notice that neither of these times are updated. The render time, which was just calculated on the fly, doesn't update either, even though it's above the one causing an error. So this is kind of the typical behavior in a React application if there is an error in a lifecycle function. Nothing happens. In some cases, you'll actually completely crash React. But in most cases, you'll get something like this. Well, an error happened. And what actually happened? Well, if I open up my developer tools at the bottom, here you can see that errors actually occurred. But other than that, you won't be able to see much. And end users don't run with the developer tools open, and developers quite often don't either. So we're using this React Safe renderer. And if I enable this piece of code and go back, we can do the same. Now if I click update, I get a very clear error. In this case, it's just an alert box, but you can use whatever UI we want. We didn't actually use an alert box, we used a component. But it will tell me exactly about what went wrong, and now I can make it much more clear for the developer and the end user as well that something was wrong. Basically, inside of React, all the lifecycle functions, so not just the render, also the component will mount, component did mount, component will receive props, etc. All of those suffer from this problem that if some unhandled exception is thrown there, then it just plays havoc with the React lifecycle model. So use something like this. So the React Safe renderer. Dan Abramov has an alternative to this, which is also quite nice, except that only covers problems in the render function. This one actually uses all the lifecycle functions, which is why we used this one. React Redbox is a nice component if you actually want to display this to an end user. So show this on the screen. We did use this during development for a while, not for end users. It's a little too intrusive for end users, but we would make something on the screen available for end users to know, to see that something went wrong, except it was just a little icon at the top. They would click on it and they would get a little display about what kind of errors occurred. But during the development, this is the kind of thing you want clearly from this .props is not a function with the stack trace and all the stuff around it. Very useful. So with that, I'm at the end. So just a short recap. Remember, HTTP on your local dev machine is perfectly reliable, perfectly fast, but in the real world, it's not, especially if you go mobile or satellite. Scaling out from 1 to 2 servers is hard, so make sure you do that right from day one. Don't start doing that for the first time when you run into load problems, because you'll scale to the second machine and you'll have more than just load problems. Use programming languages and linters and those kind of things to help you produce good code. It's not going to make your code perfect, but it's going to eliminate certain categories of errors. Webpack is great, but for large projects it does get slow, so use HappyPack or something similar. And make sure to log all your errors and actually check your React lifecycle function for errors, because they get eaten up by default and you'll miss some important clues about how to make your application better. So with that, I'm at the end. Remember my Twitter handle. Tomorrow morning I'll post these slides online, same with all the demo code. I'll push that online so you can download that. I know I'm standing between you and the beer, so I would suggest if you want to ask questions, you just come up to me after I put the mic down, and then everyone else can get a beer, or you can get a beer first and then come and ask a question. That's perfectly fine too. Thanks for being here. Thanks for the organizers for hosting this evening. Great to be here, and thank you.
All right, thanks, Maurice. And I think we can move the Q&A session to after beer session, as Maurice mentioned. So we still have some beers to finish, and we still have time to 9:30. Allowed us to stay by the Q event space. By the way, thank you then for hosting us as well. And yeah, let's proceed with some beers and talks till 9:30.